In this video, we discuss about types of multicollinearity. There are two types of multicollinearity: perfect multicollinearity and other is high or low multicollinearity. What is perfect multicollinearity? Suppose that you have a regression model y is equal to alpha plus beta 1 x1 beta 2 x2 plus error term. Your independent variables are x1 and x2. If there is exact collinearity among the variables x1 and x2, you have two explanatory variable x1 and x2. If there is exact relationship, how you find exact relationship? This is the sign exactly 1r. R is the correlation coefficient. If the correlation coefficient among two variables is 1, it means they are exactly collinear and the relationship among them is perfect multicollinearity. And in case of perfect multicollinearity, x prime x mod is equal to 0. As you know, beta is the slope of regression model. Beta is the slope of regression model and its formula is x prime x inverse x prime y. When this part is 0, it means beta is equal to 0. So in case of perfect multicollinearity, we cannot estimate slope of the regression model and its error term and error is very high. So impact, the coefficient cannot be estimated as we discuss here, and it becomes unclear which variable influencing the dependent variable, because there is similarity between x1 and x2, both independent variables, and it is very difficult for us to identify which variable influencing more on the dependent variable y. High and low multicollinearity. If the correlation coefficient between two explanatory variables is not equal to 1, means correlation coefficient is not equal to 1, it means there is multicollinearity, but this is a type of high or low. If r correlation coefficient is greater than 0.9, then here is strong multicollinearity. If r is less than 0.5, there is low multicollinearity, and the range of correlation coefficient is -1 to +1, -1 to +1. R lies between -1 to +1. In my previous video, when I am discussing about the concept of multicollinearity, here we discuss in important points of multicollinearity, that in multicollinearity we check the strength of multicollinearity, even it is positive or negative, this is not the question, but because both are dangerous for regression models, so we check the degree of the multicollinearity. If you want to see these videos, the link of videos difference between collinearity and multicollinearity and concept of multicollinearity, you can find its link at end screen. Now we see how we graphically identify strong and low multicollinearity. Suppose this is our dependent variable y, independent variable x1 and this is x2. So no collinearity because x1 has separate effect on y dependent variable. x2 also has separate effect on dependent variable y. So no collinearity. Now look another. Suppose this is dependent variable y. Independent variable x1 and this is x2. Look this shaded portion. This is overlapping. This area means that the data of x1 and x2 have resemblance, and here is the collinearity means overlapping. So this collinearity has same effect on y on dependent variable. So you can identify multicollinearity graphically with this shaded area. This is called overlapping or correlation. So this is the type of low multicollinearity. So I write here the example of high multicollinearity. Suppose this is y, x1, x2. So this is large portion. So this is the example of high multicollinearity. Here we discuss a daily life example. Suppose that these are three independent variables. First we check the effect of these two, x1, x3. Look here, x2 is equal to 5 x3 means x1 is 10, x3 is equal to 5x2, x3 is equal to 5x2 means 5 multiplied by x2, first x2 is 10, it is equal to 50, which is the value of first x3. Similarly 15 multiplied by 5, answer is 75. So identify there is any relationship between x2 and x3. These two are independent variables in a regression model. Suppose that model is y is equal to alpha plus beta 2 x2 plus beta 3 x3 plus error term. So x2 and in this model x2 and x3 are independent variables, and first we look their relationship. x3 is equal to 5x2. When you multiply every element of x2 by 5, you get the answer of x3. 18 multiplied by 5, 19, 24 multiplied by 5, 120, 30 multiplied by 5, 150. So there is relationship. x3 is equal to 5x2. So this is the example of perfect collinearity or multicollinearity between x2 and x3. And the coefficient in this case, the coefficient of correlation are 2, 3 between second and third variable is equal to 1. Now we check the relationship between x2 and x4. Right here x4. You see, we similarly add the value of in first element 2 and then 0 and then 7 and then 9 and at the end 2. These are the random numbers that we get from random number table, and we add in x3 and get the x4. And our task is to check the relationship between x2 and x4. When you check this, there is no exact relationship exist between x2 and x4. But when you find the correlation coefficient between x2 and x4, it is quite high, 0.99, which means high correlation exists between x2 x3, but it is not perfect, it is high correlation. In case of high correlation, you can find the regression coefficients, but its error standard error is quite high. And in case of perfect correlation, you cannot find regression coefficients. So here I write its detail. You can read from here, from this example. If you like my video, then click on like button and subscribe the channel Statisticians Club. You can regularly find videos, complete videos on the topic of multicollinearity, and then I also make the videos on hetero and autocorrelation. You can also see the video, a link is in front of you, on the concept of multicollinearity. Thanks for watching.